Catherine Wallace.
And I'm Megan Willard.
And we're seniors at Virginia Tech majoring in math education.
Our research revolves around finding a more mathematical and conceptual understanding of inverse functions.
So we interviewed Virginia Tech students from various backgrounds.
Some having studied or been exposed to math since high school, while others have not.
We measured them about their conception of an inverse function and how to find the inverse of a function.
Their answers provide us with a sample of how students learn and remember inverse functions.
We plan to use their answers as a foundation for us explaining inverse functions with more mathematical depth.
So here is a synthesis of all the interviews we conducted. In your own words, what is an inverse function?
I have no idea.
An inverse function is a function with a negative power, such as sine to the negative 1 of x.
Think about how to answer that.
I want to say it's like going backwards. I mean,
Like a normal function, but you can do like the reverse action of some sort on it to go backwards.
Well, basically, it takes the answer to the original function and it makes it the identity. So if you multiply the two, it makes it the identity.
In my own words, an inverse function is when you switch the domain, make it the range, and switch the range, make it the domain.
An inverse function is mapping the inputs, whatever field you're in, to the opposite of what the function does, I guess.
I mean, function is kind of like in group theory where you have group A and group B. Like this is F, and then to go back would be F inverse. I can't write this like this. I mean, that's kind of what I think. Yeah.
And for each object in the domain, it maps to one in the range, and like if it goes back to it. So say whatever you pick for x, it has to map to a certain thing in f of x, and then that would map back to the one thing on the domain.
It's basically you're undoing a function.
What if you were just given a graph of like y equals x plus 1, but you didn't know that the function was y equals x plus 1. You were just given the graph of it. Do you know how you would find the inverse based on that graph? What the inverse function would look like?
You flip it?
If I looked at the graph, I know that there's a way to find the inverse, but I don't know it. And I would first, I would look at the graph and try to find the function, and then I would try and find the inverse.
Well, in my head, I just flip the x and y axis. I know it would be some type of transformation.
Okay.
It would have to be either, it would have to be some type of reflection or maybe a rotation.
Okay.
I know it would be a transformation. I'm not sure what I would go. It depends. It's up here in the corner. I kind of was doodling. But you have y and x, and you have x plus 1, and then you switch them, no, this way. And that becomes your x. I wrote x2 and y2, and then maybe.
Okay.
I don't know if that's right.
So like do rise over run only backwards. So x, and then you add 1, but it would be 1 over 1, I believe. So you'd be going up this way, but to go back you're taking away. So this kind of notion here.
Would we take, so what would the graph of the inverse look like then?
It would be, should be going this way maybe. It's like going the opposite.
If the axes are switched, wait, no. If the axes are switched, then shouldn't it be the same?
Mm-hmm.
So if this is when they're not switched, and then when they are switched, it'd be really awkward. It would be this, I think. No.
Geographically, you basically will just turn your graph sideways, which just technically would be positive or minus the square root of x since there's two roots. So you'd have just the sideways graph.
You basically do the same thing, except you switch the coordinates of the points.
But what if we gave you an example like f of x equals x plus 1, right? So you have that function. So how would you go about finding the inverse of that, and what does that mean to you?
Well, then you would be solving for x.
Okay.
Because if you have f of x, like you can just, do y equals x plus 1, the inverse of the function would be solving for x. Because you'd be technically, then x would be dependent on y. X would then end up being dependent on y, and so, okay. So if you have f of x is equal to x plus 1, yeah, so in here, y is dependent on x, but then the inverse function would be x is dependent on y, and that would be like the inverse.
Okay. Could you, what would be the inverse of then f of s equals x plus 1?
Yeah, just take away 1 from your x, and then that would give you back your initial x. Just like if you're at an x plus 2, and then you take away 2 to get back there.
Just subtract 1.
I guess I would just do 1 over x plus 1 would be the inverse of that.
Can you give us like an example of a function and how you will find the inverse of that?
If you have a function such as a simple one, such as y equals x squared,
Mm-hmm.
which I've written down here,
Mm-hmm.
graphically, it looks like a little U shape.
Mm-hmm.
To find the inverse, you would switch your x's and your y's because you're switching your domain and your ranges. So you get x equals y squared, and then you would resolve for y. So you have x equals y squared. Solving for y, you would get y equals the square root of x. That's how you do it algebraically.
So you have y equals x squared, and to find its inverse, I would switch to x and the y, and then solve for y.
So to find the inverse, I just switch x and y and solve for y again.
When you say you switch to x and a y, what makes you think to switch to x and a y? Why does that make sense in finding that?
Because it makes sense. One, because it's a procedure I learned.
Yeah.
But it makes sense because, well, it's kind of like you think of it as, instead of having your input squared, now your output squared. So what do you have to do to the x to get that? And you have to take the square root of it. And I'm not sure if it's making sense, but...
Because if you see this is f, this is a, and this is b. X is in a, and y is in b. So if I'm trying to go from a to b, which is how I explained it, what it was, then you'd end up going f of x. You'd have to insert a x in order to get the y. But then if you're trying to go backwards, then you'll have to end up putting in a y to get an x. And that's how you end up finding it.
But some people might think, okay, if I have y equals x squared, I'll take the square root of the x squared to get the opposite, because that's the opposite or the inverse of the squaring a number. So, but the switching the y and the x allows you to think of it as, now we're flipping the function and find out what we have to do to get there, kind of.
What do you mean when you say flipping the function?
Well, I look at it like literally as you have a y on the left side, and with your outputs, you have your inputs on the right side of the equation, and you're flipping them over the equal sign to kind of get the opposite of what you're doing.
Because your x represents your domain and your y represents your range, so switching your x's and making them y's will make your domain your range, and vice versa, making your y's your x's will make your range your domain.
Okay, why do you switch the x and y, do you think? Why does that make sense to do
Because
that?
that's how I was taught to do it.
Okay.
Do you remember from high school being taught to switch the x and the y?
Yeah.
Vaguely.
I don't remember why.
Right. Okay.
It's more like memorizing a process of switching the x and y, but I don't really understand why or what's going on.